All right, lesson 6.2.1 is properties of rational exponents. So, just as a quick review, we wanted to spend some time reviewing all of the exponent rules that you learned back in Unit 5. So first of all, just number one, real quick. When we're doing this, remember if we take two bases that have two items that have the same basis and we're multiplying them. So if I had 3 factors of A times 2 factors of A, we would actually multiply, so it would become A to the 5th. Okay. Number 2, whenever you raise a power to a power, remember we're going to take 3 times 3, so it's going to be B to the 9th. Okay. When we're dividing, we're actually going to take, remember, we're going to subtract the exponents, okay? And these are going to be really important that you remember how to do these, because the next step that we're actually doing is we're actually going to do these with fractions. So m to the negative 3, remember negative exponents, all that means is we're going to change its position. So if it was up, we're going to move it down. So it'll be m to the 3rd. Okay? So remember, whenever we have a power to a product of to a power, all we're going to do is this is the one what we kind of call the distributive of power. So we're going to take x to the 3rd, and we're going to take y to the 3rd. Okay. All right, and the last one, number 6. Whenever we have a power to a power like this, a product, all we're going to do is anytime you have a power raised to another power, you're just going to multiply them. So this is going to stay a to the 2 times 3, which is 6, and 4 times 3 is 12. So b to the 12th. Okay? All right, so let's take a look at another example. Now what we're actually going to do is we're actually going to put these with fractions. So b to the 1/2 times b to the 1/4. You got to remember that, we're going to add these. So it becomes b to the 1/2 plus 1/4. Okay? Now remember, when you add fractions, you have to get common denominators. So let's change these both to a 4. 2 times 2 gives me 4, so 1 times 2 gives me 2. 4 times 1 is 4, so we're going to leave this 1. So then 2 plus 1, so this answer would be b to the 3/4. Okay? So now I have a power of a power. So when I raise a power to a power, I'm just going to raise it. So I'm going to take m to the 1/2 times 2. Remember, 1/2 times 2. When I multiply those, the 2's cancel and I get m to the 1. So if I take 1/3 times 2, ends up 2 times 1 is 2, 3 times 1 is 3, so I get n to the 2/3. Okay? Alright, next example. Number 1. So now, when you're actually doing these, here's my advice. Go ahead and take care of your property rules first. So let's go ahead and raise this to the power. So I get a 4 times 1/4. 4 times 1/4 cancels out, and I get a to the negative 1st. 4 times 1/4 again is going to result in the same thing. So b to the negative 1st. Negative 1 is going to cause the a to go down. The negative 1 on the exponent on the b is going to cause it to go down. So I end up with 1 over ab. That's my final answer. Okay? Now, remember, on this example, I'm actually subtracting these exponents. And this one has an exponent of 1. Okay? And another way to write that would be actually take a to the 3/3 over a to the 1/3. So 3/3 minus 1/3 is going to give me a to the 2/3. Okay? All right. Next example. Same thing. We're actually going to take m to the 2/3 times 18. So this is going to end up being, remember, when I raise a power to a power, I'm multiplying. So I'm going to take 2/3 times 18. The 3 cancels. 18 goes to 6. 6 times 3 actually gives me m to the 12th over 4/9. Again, when I'm raising this power to a power, I multiply. This goes to 1, 18 goes to 2, 2 times 4 is 8. So I end up with p to the 8th. Okay? Alright, nice job. Alright, whenever we're working with like radicals, two radicals are alike if they have the same index. And remember, the index is that little number that hangs out here. So these two problems would have the same index because they have that same little number outside there. Okay? All right. So these are just a couple of properties. If I'm multiplying two radicals and they have the same index, then this could be 4 times 3, which should actually give me the cube root of 12. Okay? Same likewise on dividing. If I actually have the same index, then I can put this under 1 radical, okay, over 10. 150 divided by 10 would actually give me 15. Okay? One thing to keep in mind, we will cover eventually, that you can have no radicals in the bottom. And this would actually, when it divides out nicely, perfectly, then it takes care of that problem for you. All right. So the next example. So here, go ahead and pause the video at this time and go ahead and try these. Remember, all we're going to do is, whenever we have the same index, it's asking for the cube root of 4 times 16. Okay? So the cube root of 4 times 16 would actually give us the cube root of 64. Okay? All right. And so on the next one, we want the fourth root of, we do 162 over 2. So the fourth root of 162 would actually give us 81. And you should actually go ahead and test. So let's do a little quick test on those. We're looking for the fourth root of 81. So we want the fourth root of 81. So 81, we're going to, remember, we got to hit the little Y button and see if there is a fourth root of 81. And we find out that it is 3. So this one actually would result in an answer of 3. So let's see if there's one for 64. So we need 64, and we're looking for the fourth root of 64. And it's 2.82, so we're actually just going to leave that answer since it's perfect. We're going to leave it as the third root of 64. All right. All right, so that concludes lesson 6.2 video 1. So go ahead and watch video 2 at this time.